Welcome to Mathematics Online Lecture Series by Professor K.V. Narasimhan. So in this lecture, we will discuss about few numerical methods. Particularly, in this lecture, we will discuss about how to find the solutions of algebraic and transcendental equations using bisection method. So in this method, first we will discuss about intermediate value theorem, then we will discuss about the method. Just briefly I will explain the method, then we will discuss about the problems, how to solve the bisection method using calculator. Okay. Suppose an equation is given. For example, an equation is given. For example, x cube minus 5x plus 1 equals to 0. This equation has three different roots, maybe real or imaginary. So using bisection method, we can find at least one real root using this method. With the help of this method, we can find at least one real root of the given equation. So what is the methodology? So this is totally iterative method, Then how to apply this method? Okay. Suppose left side is treated as fx equals to 0. Okay, fine. Now suppose if you assume y equals to fx and also equals to 0, we will discuss later. Now if you draw on the graph paper or graphical representation y equals to fx, okay, this is a curve y equals to fx. Whenever y equals to 0 on this curve, y equals to 0 is nothing but the point of intersection. This point of intersection is called root of the equation or solution of the equation. So now we will find this point of intersection y equals to 0 at y equals to 0 and y equals to fx, the point of intersection of the curve y equals to fx and y equals to 0. So point of intersection of y equals to 0 and y equals to fx is called the root of the equation. Then how to find the root of the equation? We have several methods. So in this lecture, we will discuss about bisection method. So before going to the bisection method, so first we will discuss about intermediate value theorem. Intermediate value theorem. This theorem is also very easy. Suppose fx is y equals to fx. Let f is a function from one point A to B, a particular point A to B, then no problem. From A to B to R is a continuous function. Continuous function means there is no discontinuous points from this point to this point. If you observe at this point, there is no break here, no discontinuous points. So continuous and at a particular point fa and particular point fb, the product is if the product is less than 0, nothing but if f of a is positive, f of b must be negative, or if f of a is negative, f of b is positive. Nothing but the product of f of a and f of b is negative, then what do you say? If you observe this diagram, from a to this point of intersection, the function values are negative. Okay. So at this point a negative, at this point, after this point of intersection, positive. Okay. The function value is positive. Then what do you say? Then what do you say? Then there exists some c belongs to open interval a to b. From a to b, point a to b, there is some c between a and b such that f of c equals to 0, f of c equals to 0, or the function intersect y equals to fx, the curve intersects the x-axis at the point c. Now the c is nothing but the required root of the equation. Okay, this is about intermediate value theorem. So we will use this intermediate value theorem for applying bisection method and also regular false method and other methods. Now coming to bisection method. What is bisection method? This is very simple methodology. Suppose a function fx is given. Suppose fx equals to 0 is the given equation, with a given equation. Okay. Suppose if you draw the curve on or geometrical representation of the curve. Okay. Now this is point A and this is point B. This is curve y equals to fx. So using intermediate value theorem, first find the location. So using intermediate value theorem, easily we can find the location of the root. The required root lies between A and B with the help of bisection method. Okay, now bisection of these 2 points, nothing but midpoint. Midpoint is some say C. Now observe here the point of intersection lies in this off or in this off, from A to C or C to B. Just physically observe. So now if easily we can find it. The required root lies between A and C. Now take the midpoint of A and C, suppose some C D. Okay. Again take the midpoint of these 2 and again finally we reach our required root. This is nothing but bisection method. So in this method we will use a simple formula for finding the root x1 plus x2 by 2. Midpoint formula. So x1, the x1 is nothing but first one. This is x1, this is x2. Simply I will call it as AB or x1, x2, then no problem. Then how to apply this method? Okay. Now we will discuss the problem how to apply our method. Okay. Okay, I will write the question here. Find a real root. Find a real root of the equation x cube minus 5x plus 1 equals to 0 using using a bisection method. Bisection method. Okay. How to apply that method? First, assume fx equals to the given expression, left side expression of the given equation. Okay. First, we will find the location of the roots using intermediate value theorem. Very simple. Put x equals to 0. What happened? X equals to 0, 1, positive. Okay. Put x equals to 1. What happened? 1 minus 5 plus 1, that is minus 3, negative. Whenever you will get alternatively negative positive or positive negative, then the required root lies between the corresponding values, nothing but intermediate value theorem, negative positive or positive negative. Suppose f of 1 is also positive, then find f of 2, f of 3, f of 6 and so on, and also in the similar way negative values, minus 1, minus 2, minus 3, put minus 1, minus 2 and so on. Okay. Whenever you will get alternatively negative positive, the required root lies between 0 and 1. Okay. So our required root lies between 0 and 1. Well, now I will explain with a tabular form. Very simple tabular form. No need to write in words. Just simply we can write all the values in tabular form. x1, x2. Okay, I will fix 3 decimal places. Formula x equals to x1 plus x2 by 2. Then no problem. The fx x cube minus 5x plus 1. Okay, close. Okay. I will write in red color the values in red color. Okay. At 1, so the required root lies between 0 and 1. Write 0 here and 1 here. At 0, our function value is negative, sorry, positive. So just symbol, just only write the symbol. This positive denotes at 0 the function value is positive. At 1, the function value is negative. F of 1 is negative. Okay. Now find the midpoint of these two, nothing but 0 plus 1 by 2. 0 plus 1 by 2. Then I will explain with the calculator. Simple, I will take a and b instead of x1 and x2. So open bracket, alpha a plus alpha b divided by 2. Now press calc, a value 0, then press equals to button, b value. So I will take it as a here, a, b, just only for understanding. B value is 1. Then press equals to button, you will get 0.500. Fix 3 decimal places. Okay. Now don't press AC button. Now type this equation, alpha x power 3 closing bracket minus 5 into alpha x plus 1. Then press calc button. X value 0.500. Now you will get negative value minus 1.375. Whenever fx is negative, write the x value in negative column. Nothing bad. Now I will explain. So write the other value same. If fx is negative, write the x value in negative column. If fx is positive, write the x value in positive column. This is nothing but the required root lies between these two, 0 and 0.5. Okay. Again apply the iterative same apply this method. For this purpose, press copy button at the top edge. You will get the previous equation a plus b by 2. Now press calci button. A value is 0, which is shown. Now press equals to button. B value is modified 0.5. Then you will get 0.250. Now for finding the fx value, again press the copy button at the top edge. Okay, you will get the same equation. Press calci button. Now type 0.250. You will get minus 0.234. Again it is negative. Write the x value in negative column. Negative column is this one. Again the required root lies between 0 and 0.25. For finding the next iteration, press copy button at the top edge, calci button 0, already 0 is shown, equals to button. B value is modified 0.250, then value is 0.125. Now for finding the fx value, press copy button at the top edge, then press calci button, then press answer, then press equals to button. You will get answer or 0.125. Now it is positive. It is positive. Then write the x value in positive column 0.125. Now second value is same. Repeat the same process until x is repeated or fx value is less than or equals to 0.0001. Now this is bisection method. So in this method, suppose after 3 iteration, the required root is 0.125. Okay. So in the next lecture we will discuss about another method, regular falsive method. Thank you very much.